Find the Laplace transform using the definition of the function cosh bt. And by the definition, so here is the definition. Laplace of lowercase f, that is denoted by uppercase f as a function of s, is this improper integral 0 through infinity of this kernel e raised to negative st and the function itself dt. So Laplace of cosh bt is in fact this cosh bt times this kernel e raised to negative st from 0 through infinity. Okay, this is just from the definition. And this is improper. Let's change this into 0 to a, finite a, and we let a go infinity. Okay, now we need to evaluate this integral. We got a product of two functions, so we use the integration by parts. So let's say u is e raised to negative st and remaining is dv. This is u and remaining is dv. So we can find v. By the way, antiderivative of cosh is just sine hyperbolic, and this is a derivative with respect to t. And the formula, we know that when we have u dv, that's just u v minus integral v du. So u times b minus b times u. So we get here this limit a going to infinity of, then we have limits u v, so v is this, so 1 over by the way, this is b, I was supposed to write b there, 1 over b e raised to negative st sine hyperbolic bt, and we have limits from 0 to a, that's u v part, minus integral, so 0 to a v du. So du has negative, is minus, so it becomes plus v times du. Okay, this is by the way b. Then when we multiply s and b, we can pull outside, s over b outside, that leaves e raised to negative st, and this sinh or sine hyperbolic bt dt. Okay, now we can compute this limit. By the way, this limit for everything, so limit for everything. And look at the second part, we have another product of two functions, so we need to use the integration by parts one more time here. At the same time, for this function though, we can take the limit, okay, and which is, and we have to keep writing this limit. For this part, before we take the limit, we need to evaluate this function at the upper limit minus lower limit. So limit a going to infinity, just from this part. Now upper limit means replace t by a, so this is 1 over b e raised to negative sa sine hyperbolic ba, evaluating this function at the upper limit, minus evaluate this at the lower limit and plug in t equals 0. Sine hyperbolic 0 is 0, so everything will be 0. Okay, that's just for this part. Plus, let me write this one more time, 0 to a e raised to negative st sine hyperbolic bt dt. And when we take this limit, what's going to happen is when s is positive, okay, let's say s is positive, then a is going to infinity, so e raised to negative infinity, so the whole thing goes to 0 if s is positive. Now we need to work on this. So this is in fact limit a going to infinity of this, and we have to use integration by parts here, integration by parts again like last time. So same here, so u is e raised to negative st and dv is the remaining sine hyperbolic bt and dt. So du is with respect to t, derivative is negative s e raised to negative st, and v is antiderivative of sine is just cosine, no negative though, cosine hyperbolic bt over b. Okay, so we have now, this is gone, this is 0 0, so s over b, and for this integral using this formula again, okay, ub minus bu, b du, so we have s over b and inside ub, so let's multiply these two, so that's 1 over b e raised to negative st cosh bt. Okay, that's ub part, and we need to evaluate from 0 through a, minus integral v du, just using this formula, v times du. Okay, du has negative, that makes this positive now, so if we multiply sb we can pull that outside, and that leaves e raised to negative st and cosh bt. Okay, and dt, and we have this big bracket. Now let's simplify this. This is limit a going to infinity of s over b outside. For this function, let's evaluate at the upper limit minus lower limit. Okay, that means replace t by a, so 1 over b e raised to negative sa cosh ba, that's the upper part, upper limit, minus lower limit, let's plug in 0, 1 over b times e raised to 0 is 1 and cosh 0 is also 1, so this is pretty much just 1 over b plus this is s over b. Now this integral is same as the top, 0 to a e raised to negative st cosh bt. Okay, this is with this limit exactly the Laplace transform of the original function. Okay, with this limit combined, this part is in fact just the definition. Okay, Laplace of cosh. For now, to simplify this, let's say this is as uppercase f, because function is lowercase f, so this is, let's say, the Laplace transform be uppercase f. Yes. Okay, so let me copy this one more time, 0 to a e raised to negative st cosh bt dt, and this is in fact let's take this limit like last time, when if s is positive and when a goes to infinity, so e raised to negative infinity 0, so this is pretty much 0. So we have now s over b, this is 0, minus we multiply with 1 over b, so s over b, 1 over b, so that's negative s over b squared. Okay, plus s over b, s over b, s is square over b square, and limit of this. Okay, this with limit is just the Laplace of cosh. I mean, that's exactly what we have or here in this step. I mean, 0 to a means 0 through infinity when a goes to infinity here, so that's the Laplace of the cosh, and we are saying fs, so let me write that as fs. Okay, so this is in fact, let me write here, that is Laplace of lowercase f, the given function fs is equal to, we got negative s over b squared plus s square over b square, that Laplace again. Now we solve this equation for uppercase f. I mean, that's what will be the Laplace transform of lowercase f which happens to be cosh bt. So let's move this to the left side, means subtract this here, s square over b square fs, and this is gone. Okay, and we have now one copy. Here is the s square minus b square copy. So when we factor fs out, this is 1 minus s square over b square copies of fs is equal to negative s over b square. So this fs is just negative s over b square divided by this fraction, and we can combine these two fractions. So b square minus s square over b square. So this is b square minus s square over b square. Okay, so that is in fact this lowercase uppercase f is the Laplace of uppercase f. That is, one more time, this is in fact Laplace of lowercase f, which is cosh bt is equal to, when we simplify, look, bottom b square cancel, then we are left with negative s over b square minus s square. But if we factor negative out here, then we can flip, we can switch the order. This becomes s square minus b square, okay, with negative out, and negative cancel. So this is pretty much s over, just flip, and we get s square minus b square. Okay, final.